Welcome to SSI Meetup. Today is a great day. We have Kim Hamilton Duffy with us, and she will be talking about DIDs Demystified. And this is a really cool thing because she will explain to us how the DID Bitcoin reference method works. And as you know, there are many different methods for DIDs, and this is a very specific one we will be doing today with Kim. And she is the CTO of Learning Machine, which is a name I love. I really think it's a really cool name. And yeah, so she will be talking more about all this in a couple of minutes. But if you go to the second slide, I will tell you briefly what this is about, why we're doing SSI Meetup, and what is important for us. So basically, SSI Meetup has been born to empower global SSI communities. And this means that we want to have companies, organizations, and people participating to share knowledge about what SSI means and how it's important, and help and create tools for everyone in the world to participate in the SSI space. And this is open to everyone, so it's not a corporate, government, or anything initiative. Everyone can participate, and if you want to participate, please get in touch and let us know. And what is also important is that everything that Kim will be sharing with you today will be shared with the Creative Commons by Share Alike license. This is basically an open source license, which means you will be able to download this presentation. We will be putting the webinar up, and we will be putting the slide share up, and we will be also putting up the Google Slides so that you can reuse them wherever you are in the world. You will be able to use those slides, and you will just have to reference back to SSI Meetup and to Kim in this case, because you produced and say that this is the source. But this will allow you to gain from Kim's knowledge and just share it with the rest of the world as we all together build global, local SSI communities to push forward with this. If you have any questions during the webinar, please just write into the system. You have a chat system that we can write in, and I'll then interrupt Kim and bring up a question, and she will answer. And yeah, and I'm sure you will love this. I'm really excited. And Kim, thank you very much for being with us today. It's a pleasure to have you with us.
Thank you, Alex. It's great to be here. So I wanted to start by who I am and how I got involved with self-sovereign identity. I am CTO of Learning Machine, and Learning Machine and MIT Media Lab work together for the BlockCerts open source, open standard library. So I was the principal architect for that. And BlockCerts is a set of libraries that you can use, and standards that you can use for blockchain verification of credentials. So when we started that, we were using an open badges schema exclusively. Through our efforts and overlap in interest, we stumbled onto the verifiable credentials group. So over, this is an interest that started quite a while ago, but Nate Otto of Open Badges and I have been really keen and actively working on Open Badges and verifiable credentials alignment, because Open Badges has a very rich vocabulary for educational, occupational credentials, but then verifiable credentials have these other advantages, being a lightweight backbone of a schema, having a rich set of signature suites associated with it through JSON-LD signatures, and probably most importantly, the related work involved with decentralized identifiers. So yeah, I first found out about DIDs a little over a year ago at Rebooting Web of Trust. And so the BTCR method spec specifically is something that Christopher Allen first described, and he had been working with Ryan Grant very heavily to sort of design out all the details. I wanted to understand DIDs more because they were very complex the way people were describing them, and I liked the BTCR method spec. The appeal was that it seemed very simple, a very good way to sort of understand what DIDs are and start working with them. So yes, I've gotten now very into decentralized identifiers. Now I am co-chair of the W3C Credentials Community Group, and we are incubating the decentralized identifier specification draft, which we expect to soon turn into a working group. We're working on all of that right now. Some quick context. So to Alex's point about being able to share and reuse slides, these are some of Drummond's slides from SSI Meetup 2. And at this point, I encourage you either to, if you've not seen this, it might be good to either watch that now before this one, or you can comfortably go on and watch this afterwards. But here's the context of that. So in his second SSI Meetup presentation, he shows this stack, which is really useful to orient yourself in the emerging open standards for self-sovereign identity. I referenced this one, verifiable credentials, that's undergoing a working group right now that is basically expressing claims. Now, jumping down several layers, it's the DID or Decentralized Identifier layer, and that's what we'll be talking about in this presentation. Now, specifically in Drummond's talk, he mentioned, he showed an example of a DID string. And it's actually this one up at the top. So you have, the scheme is actually DID. The method is in the second position. So from here, you can, from this prefix, you can see, is it a sovereign DID method, BTCR, etc. And these are some of the more popular DID methods mentioned now. When I say popular, I mean ones that we've been working with the longest. It's still very new, and people are contributing new ideas all the time. So yes, we are talking about this one specifically, the Bitcoin reference. Okay, so let's step back for a second to ask, why is BTCR so interesting? So as I mentioned, in the educational, occupational, verifiable credentials space, what we're talking about is the idea of issuing credentials that recipients can really carry with them their whole lives. So with that, you have to be very careful about issues of longevity. And where that really comes up is in the subject of a credential, meaning who is the subject that the credential is describing. And there, the biggest challenge that happens is identity. And initially, in both block certs and open badges, there was no real solution. DIDs weren't even on our radar yet, or various forms. For open badges, open badges predate DIDs. Not wanting to sort of solve identity poorly, we use solutions that were as good as we could expect at the time. But even if you are doing something with a credential that you can claim cryptographic ownership of, we all know that maintaining cryptographic keys is a huge usability problem. So if you're going to propose to issue people credentials that they, prove ownership of through cryptography, you really have to sort out these usability issues first. And DIDs was sort of what made everything come together for me. That's when I realized that's the solution that we need. Now, even still, so again, we're talking about a little bit over a year ago. A lot of DID methods are in development right now. BTCR stood out because although it wasn't implemented yet, the blockchain was already available. In some DID methods, the specific chain and rules of that chain are part of the DID method, whereas the Bitcoin blockchain already existed. So it's a very simple implementation, minimal feature set, which, as you know, in security or any sort of risky new technology, that also has advantages that it's very easy to reason about. I also found that it was a really good baseline from which to understand what some of these other more advanced DID capabilities are. And we'll talk briefly about those later. But yes, basically these combine the ability to just get started right away, even if the libraries that you're using aren't ready be used in production, there's something you can start working with to understand how you'll be using it in your ecosystem, which I think is very valuable for developers and technologists who are trying to experiment to think of what would a DID wallet look like and things like that. Okay, so first we're going to talk about how BTCR works. And again, BTCR stands for Bitcoin Reference DID Method. So we'll show an example, see what it means to, where this thing lives, how to create and update them, and also how to resolve. I will I'll show a live demo. I wasn't sure at first if I could, but for these parts, the creating, updating, and resolving. And then also that will show, at least for parts of those, how you can try to experiment with it yourself afterwards. Here's an example BTCR DID right here. So again, we have the usual prefix that you'd expect. And then here's the specific ID. And what this is in BTCR, so one thing for DIDs backing up generally is each Bitcoin method, the string that you see in the last part, it will be up to that DID method to figure out how that's handled, what it means. And there's something called a universal resolver, which I have in the references, something that's been worked on by Marcus Sabadello, that understands how that works across many DID methods. So again, we're in BTCR space, and only BTCR, like this string only makes sense in BTCR for the most part, but a resolver can handle it. So in BTCR, this is an encoding of the following information: which Bitcoin network the DID was issued on, the block height in the blockchain, and the position of the specific transaction in the block. So this format actually is, it's based on Bech32 encoded transaction position references. When I say extensions, we're actually proposing some additions for different chain encodings and indexing into specific outputs. We don't need to get into that right now. I have references at the end for more details about that. But basically from this, I will say that the first character here, from this we know it's a testnet one. The rest of it, you'll want to use one of our libraries to help resolve it. But from this string, a resolver that understands BTCR DIDs can generate a DID document. And as a quick preview, this is what that looks like, but we won't get into details right now. Okay, so let's go back to the string and talk about where it lives on the blockchain. So again, we have DID, BTCR, and we have all of this stuff. So again, this first position, and unfortunately I reused X here, I should have used a different one. But in any case, this first character would say, am I looking at testnet or mainnet essentially? The other information in the rest of the string is saying which block in the entire blockchain you're referring to and which specific transaction within that block you're talking about. So this helps you just locate that transaction to start with. So yeah, so in this case we say we resolve that to a specific blockchain, this block, and this transaction within the block. And then so next we'll go into sort of how the next level works of, once you find that transaction, what can you do with that, what it means. So this is just the same picture from the previous slide. So what happens here is, okay, so we had our BTCR DID, we looked up our transaction, it had some inputs and some outputs. Let's talk about what the various things mean. So it looks like a fairly normal Bitcoin transaction, but it might have an op return. and then we'll get into what that means. Okay, so just like any Bitcoin transaction, you have an address, you signed the transaction there with the private key. You have an output in this simple example that goes to another Bitcoin address, and it's pay to public key hash. Okay, so then optionally, you might have this op return that points to additional metadata or additional data actually you want to merge into the DID document that results. And we'll take a look at that a little bit later. So now at this point, you have a BTCR DID transaction. Resolvers know what to do with that. You can use the DID associated with it to do some basic things like sign verifiable claims. You can possibly use it to authenticate with it. We haven't gotten into yet how that happens. But let's just talk about, say if you wanted to update that DID. So we take this one and you spend that output, and you basically form this chain of transactions so that the way that you tell if a Bitcoin reference DID is the most current one that you're referring to, you just walk the chain until you find the latest unspent transaction output. Okay, the next few slides will walk through what it means to resolve a BTCR DID. So at a high level, the steps are, we look at the transaction, we build what we call the implicit DID, meaning this is all just information we get from the transaction itself. If there's what we call a continuation DID document in that op return field, we look up that data, and then we build the final constructed DID document. So let's look through how that works. Actually, I may start with my slides and then jump over to the playground. If you want to pull up the playground right now, though, just follow this link down here, BTCR TX playground. So when you pull up the playground, you can see that there are some BTCR DIDs pre-populated in the combo box just so that you can experiment with it. But it's also free-form text entry. You can enter your own. But the idea is that, so you would enter the BTCR DID string, and you would say convert from TXREF. You could also enter it if you knew the blockchain and the TXID height, TXID or block height and position. You could look it up that way, but this is typically what you would be seeing. So one quick note is, because I'm a little unsure of the audience and sort of hoping for a broader audience, what I'm describing here is pretty low level. What most people will be interacting with is layers of libraries on top of this. So what we're doing right now is peeking into what a resolver is actually doing once it encounters a string. So that's mostly useful if you're trying to see in general how DID resolution looks, but then specifically for BTCR, I'm showing what it's doing. So if you click on this convert from TXREF, you'll see that over here, so it first did the step of resolving this TXREF, this DID string into the specific location. So it's on testnet, this block height position. And then there's stuff below. And so the stuff below is what we'll talk about. So in the first phase, I mentioned this is where we just take the information that we find from the transaction itself. And that's kind of interesting because if you happen to have a Bitcoin transaction from a long time ago, and whose output address you still own the private key for, you can actually start working with BTCR DIDs right away. You can, in fact, start signing verifiable credentials with that right away. So that's something that we can talk about a little bit later. But to get into what actually happened there, this public key is actually just the hex encoding of the public key used to sign the Bitcoin address. So notice this is a little bit weird. You're used to Bitcoin addresses, like you would expect a Bitcoin address here. But actually, when you look up the Bitcoin transaction, once it's already signed in on the blockchain, from the transaction, you can look up the hex encoded form of the public key. And we use this because this is actually a signature, or sorry, a key specification, one of the W3C standards that I'm referring to. And so we've chosen to give a default capability of authentication to that public key that was used to sign the transaction. We debated over that, but the reason that we did it is, basically a BTCR DID, if we didn't have that, it would be useless unless you had the op return field populated with continuation data. So we thought authentication would be a reasonable default capability to add. Now, if what I'm saying now causes many questions, that's good, because I'll have linked to issues at the very end, where all of these design decisions I'm talking about are referenced. Because this is sort of the interesting part about writing a DID method right now, is that there's a very clear document you need to build. Depending on the blockchain you're using, you have different options, and so there's a lot of design decisions that go into actually thinking about what capabilities you want to provide. And of course, you're very cautious and you want to propose a very safe, secure method as well. So we've chosen to provide authentication. Down here, this exists only because I did have an op return in the transaction it referred to. And we'll get into what this means later. The Satoshi audit trail is just metadata specific to the BTCR method. You won't see this in the DID spec, but you will see it in the BTCR method spec. And we'll get into some of those contents in a little bit. Oh, sorry, I guess I meant to be clicking on this as I go. So yeah, the first arrow is meant to say, yeah, we're enabling authentication. We have the continuation DID document and method-specific metadata. Okay, so in the part where I mentioned the continuation DID document, that is this DID description phase 2 part, where if there is a reference in the op return to more data, we look up that information. And for now, for phase 2, we're just considering that we're looking it up. We'll deal with merging it in the next phase. So what this means, this one isn't especially interesting, but you can actually add additional DID capabilities or sort of terms that you see from the general DID spec. So that's a useful hook for something as simple as BTCR, because we're dealing with a very limited amount of space. We're dealing with a transaction that's issued very fairly static, except for updates. But this continuation document is a way to pull in additional information. Let's see. So basically in that phase, what we did is we took the link in the op return and we just looked up that JSON data. So we have that right here. Then lastly, in this phase, we merge in that additional data. So notice that before we just had the single transaction signing key, but now we added in this additional part. This has been abbreviated just for brevity. We've merged in this additional key and given it also authentication capabilities. So this is this other RSA key that we can use, and so on. We could add additional services, for example, if we wanted to. Actually, at this point, let me skip to the live demo. Okay, so I come to the playground and I'm going to look up this one. Okay, so again, it looked up the transaction information. From there, it goes to the Bitcoin blockchain and does DID phase resolution phase 1, which is here's all the information from that blockchain transaction. In this service, including the op return, which got populated in this service term right here. So then we have a URL here, which in phase 2, the resolver gets those contents and just shows them right here. Then in phase 3, what's happening is it's merging in those public keys and any other types of data that you added as part of the continuation. And let's go back here for creation. Okay, this one actually walks you through it, and there is a little bit of delay. For example, if you need to add funds to your testnet address, there are testnet faucets if you want to work along with this. So follow the steps here. You can basically create 2 testnet addresses. One is the one used to sign that transaction, and you need funds in it. But then you need this output address because that's the thing that you use to indicate whether it's spent or not, and you would basically spin that to rotate the key or update it. And again, so this is very insecure. So this is why we're saying it's in a web browser. So we're don't only use testnet here. I should have said that first. But so yes, so we're assuming testnet right here. The libraries that are behind this, you can use independently outside of a browser. So just keep that in mind. So yeah, if you need to have testnet funds to initiate this, you can just do a search for a testnet faucet, because I find different sort of availability in that it's not worth keeping a list. You should just do a search and you'll find something. And then at that point, it'll prompt you to enter an address. And then you just put in this input address you did here. And then lastly, you can put in your reference. Like say this could be, in my case, I put in that link to the GitHub page, but it could also be some content in IPFS. And, again, this is in a browser, so you're just putting in your secret key. It's only testnet, no real money here. But just from this site, that's where you can go create the DID. Alex, quick audio check. I got a warning on my.
I hear you right. It's all okay.
Okay. Okay, excellent.
Awesome.
Okay. There were a lot of things that I sort of jumped over that are pretty subtle. So we're going to spend quite a bit of time talking about the limitations of what I showed you, and then also talk about what we're working on, and then we'll go through what you can do with the BTCR DID, and then expand to talk about okay, so now that you understand this really simple DID method, what are some of the other things that other DID methods can offer? Okay, so the first one that I mentioned was that the creating a DID, a BTCR DID, we're running that in the browser. We're telling you to enter your WIF, and so that's just not necessarily a good idea to do. But we designed it so that the libraries are available independently. But the Node.js libraries have other limitations that I want to warn you about, because the main purpose of it was just getting this DID method up and usable. We have other extensions to these and other options that we're considering for more of the production ready approaches. And so one of those would be when you are looking up the transaction, the Bitcoin transaction, what we're doing is using just Bitcoin explorers like block cipher or something like that. We're just using these APIs to look up the transaction. And there are availability and sometimes other concerns. What if someone is hacking you? What if you get the wrong data? It's a single point of failure, basically. There are small workarounds that one could do even within that system. Like, say you could check multiple Bitcoin explorers, compare them to see do they agree, but that's still not necessarily the way you would want to go. Again, depending on sort of the security attributes requirements of your application. When we're prototyping it with the first BTCR hackathon, I was the one who went the explorer approach because it's easiest to just progress quickly with that. But other people, Ryan Grant, for example, he experimented with C++ libraries and using Bitcoin nodes, and also variations on top of that. Like, one of the problems that we had, though, is basically the idea of indexing into the chain. So the problem again, so you started with this string, and recall we had to look up a transaction, but say you find out that transaction is spent, then you have to go to, you have to find the appropriate output and then go look up that transaction. So you might be doing quite a few lookups. So that's something to keep in mind that we don't really have a good solution for in any of the samples that you see right now. So yeah, there will be a trade-off there, certainly in terms of usability, resource requirements, like say, certainly if this is something you want to run in a mobile wallet, but then also confidence in the information that you're getting. So Ryan and Dan Pape, they are still working on their C++ libraries, and they are addressing these with some more robust options, and we'll be getting to that in the various libraries as well. I'm going to point you to his libraries at the end to show, if you want to follow up on that, because this is something that we're all very much actively working on right now, and love to have people involved. There are other quirks that came up. So one thing I brushed over, first of all, I'm going to get to the continuation document. So in this service endpoint, so this I put in just raw GitHub user content, and this is my DID continuation document. We are encountering an interesting place where, okay, so say what I wanted was to have my continuation document in an immutable store, like IPFS. So that would be ideal, because then the data pointed to there is, something that is, if the link gets you there, that that's the correct data, basically. The problem that we encountered with a lot of the DID spec was the need for signatures on the data. So we have a chicken and egg problem. So because we only know this transaction ID after we create the BTCR DID, we don't know how to sign that until after it's created. So for example, in this case, what I'm doing is saying, that I'll put the data here, and what I should do in my example afterwards is then sign it with this DID, and I can do that because it's a mutable store. A design decision that you'll see referenced in the issues that we're still talking through is the idea of, okay, so what if you want to put it in an immutable store? There's no real good solution there. So the approach we're considering is that the transaction on the signature is effectively the signature on the transaction is effectively the signature in this document. So it doesn't need to be signed just by virtue of signing the transaction. If this is in an immutable store, then that counts, and the DID resolver can handle that. So right now we have a little bit of that as a sort of special case, like, so then that brings up the question of, do DID resolvers need to be aware of which are mutable and which are immutable stores? The other thing is confirmation time. As with any Bitcoin transaction, you don't want to accept a signature that someone signed with a BTCR DID if it has no confirmations. You have no confidence in that. So something that we've talked about a lot is just, what are timestamps? Like, timestamps is something that is referenced in some of these signature suites that we're talking about, but we're still sort of going through the spectrum of concerns that are relevant for finding a good timestamp or a usable. And really, we're pretty confident it will be a range, just like in Bitcoin payments. For higher stakes cases, you want more confirmations, but that's something we need to address in the DID method spec. So what can you do with the BTCR DID? The interesting thing that I mentioned is, if you have a Bitcoin transaction, if you have some money in a Bitcoin address just hanging out there, you happen to still have the signing key, you can sign verifiable credentials with it, and you're working with DIDs right now. And actually, by the rules that we set here, because you have a default authentication ability, you could actually authenticate with that as well. Now, the reason that I think that that is set in with lots of caveats is that there's not really the ecosystem to support that now, but it's useful to start experimenting with it. Okay, so the other thing I wanted to mention is the capabilities that I discussed and that are currently referenced in the BTCR method spec are pretty straightforward. They are the core required ones by any DID method, which are the CRUD operations, create, read, update, delete, which is effectively revoke. And there are capabilities like signing a verifiable credential and authenticating. But you've probably heard of all these other great capabilities enabled by DIDs, and which actually we're very interested in terms of, long-lived verifiable credentials. And those are things like, it's like social recovery. So the idea that you could specify, 5 people, 3 of which can vouch for you if you happen to lose everything, you lose your phone. Other DID method specs, you'll see reference MFN signatures, and also guardian manage. This is something that is sort of it occurs in Sovereign and I think a couple of other DID method specs. But it's the idea of something more like, you don't necessarily need to be, sort of owning cryptographically that key, but you are sort of trusting a guardian. And this can make sense in many scenarios. One thing that is actually interesting that I learned from Drummond, in fact, at a recent rebooting Web of Trust, is that I think that a lot of us in the self-sovereign identity space think about social recovery, and we think, that's really great because I can, own my identifiers, and I can also say, like, if I can not worry about losing all of my records because I've set up these set of people that I trust that can vouch for me. The interesting thing, though, when people were doing sort of usability studies on that, was that people didn't necessarily want to ask their relatives to sign for them. Maybe this is just the general usability thing, but they would be okay with if a company that they trust, trusting that there's a lot of, that's a very loaded term, but if it is a company like, say, Google or something, and they're offering this and they can offer you very quick turnaround time, a lot of people were willing to sacrifice, complete ownership with, sort of convenience. And so that's more relevant in the social recovery space. In guardian managed cases, that can be very relevant for, say, something where you want to provide identifiers for a large amount of people very quickly. You know, we're in various states of the sort of technology primitives being available so that you can actually work with this. So one thing that's really appealing is that a lot of DID methods are approaching extremely different use cases. And so I think that's the biggest distinguisher right now. And that's why no one in the space will even say like, this is the best DID method or anything. They're all just, they're doing such unique things. And that's another reason I find this space very interesting, is that we're still trying to find a match of solutions for use cases. Where BTCR stands out for me is really the simplicity, the fact that you can start using it right now. You know, even if these certain these other capabilities might be added, but you will probably find that other DID methods will provide more conveniences, like updating may be more available, like a lighter weight service, things like that. So that's really the main thing to keep in mind when you're looking through different DID methods. They're making different design and convenience trade-offs throughout. And so I think, you know, it'll be interesting to see how everything evolves, basically.
Just
oh, yeah.
one little question here coming from David. David is asking, what about just omitting the ID attribute in the DOD?
Right. Actually, that is something, okay, there's two parts of that. And if it's all right, I'm going to go back to that. Sorry, one second. Okay, so say this is in this continuation, we actually sort of have done that. So notice that, okay, this example is sort of cheating. It's written as if it's in an immutable store, but it's actually in a mutable store. So this is actually what it would look like if it were in IPFS, because we don't know the DID yet. So what we did is we provide just this suffix, this, you know, sort of fragment, and then the DID resolver merges this with the DID that it knows, you know, after the transaction's been created, and it combines those. So there's actually two parts. There's the part that, you know, in some cases we leave off the ID entirely. In other cases where it's needed, we provide a fragment. And this was something that I think we still have it called out. It was part of the spec that at the time we were originally working on, it was sort of unclear whether we could do it, but we decided that for this sort of case and to allow you to use immutable stores, which we knew people would want to do, you know, we knew we should support that.
Yeah.
The last thing, oh, sorry.
David is just saying that that he meant the ID attribute at the top level of the DDO.
Yeah, so actually this is, okay, so we're talking about two things. This one is a constructed DID document. You can build that even if this continuation DID document is in an immutable store. So note that this is a partial DID document that doesn't have that ID. So not just this, but also that. If it's in a immutable store, we actually, because we don't know that ID, we just leave it out of the continuation. However, the DID resolver is piecing together information that's known. Like this is, at this point that someone presents you a DID, a transaction exists. So a DID resolver can go look up the implicit data, it can look up this continuation data, and then it can merge it into this whole thing. But note that, say, like if this were this key 2, if that were obtained from an immutable store, the resolver would be splicing this on, because we didn't know that at the time we created that document in the immutable store. Does that make more sense?
I think so. Yeah,
I'm not sure if I
so.
see the chats right now.
Let me check. He's just answering. Oh yeah, he's saying thank you. Yes. So,
Okay, cool. Yeah. And so I want to come back to that actually, because that is really the interesting part about BTCR is that, and I think one of our huge struggles from the beginning was that so much of what we wanted to express was blockchain dependent, Bitcoin blockchain dependent. And so we were initially going down a path where there are a lot of, Bitcoin specific artifacts. And through designing this sort of to figure out things like, well, how do we deal with storing, additional data in an immutable store, all of these things like that, we got to a good state or a better state, I guess, where we felt like we can build something that looks like what everyone else is building, so that this can be used anywhere, for say authentication, whatever, anything accepting DIDs, and that method specifically knows how to handle it without inheriting all of this unnecessary method specific stuff. But that said, as I mentioned, quite a few of the details that I've gone through are still things that we have GitHub issues opened on. And so I encourage you to read some of these references that I have. And let me go back to it. In fact, this is where I have a lot of the references for how to get involved. So one thing I do want to bring up is that, I've only been in the self-sovereign identity space for a little over a year. So don't think that everyone, the space is crowded or whatever. We're looking for people to get involved at all levels. I've been mentioning some things that would probably appeal more to developers, but we also need things like user stories, white papers. If you're interested in this area, we can use all forms of help. And there's a lot of ways that you can get involved. So I've called out sort of a range of options. Up at the top, we have some of the more, what I call like ongoing incubation. This is where the DIDs came from originally, from years of development, specifically in the Internet Identity Workshop. Rebooting Web of Trust is a related one where we've actually spent some of that time prototyping DID methods and working on the specification. We have hackathons, and even though it's called hackathon, we actually do, people work on this whole range of things, not just prototypes, but sort of user documentation, things like that. That's something that it's really hard because I think a lot of people who are building the methods are not having time to write about it. And so we're really eager to get people thinking about it and able to talk about it in better ways than we have. Another area is blockchain commons, is something that Christopher Allen has started. And he's doing a lot of initiatives sort of based on BTCR, some of the more advanced capabilities that I briefly referenced but haven't really got into. But probably the best way to do that is just reach out to him on Twitter to find out more information. There are still other ways. So we're working on draft specification. So for the DID specification itself, the draft, we're working on that in the W3C credentials community group. Also in there, we're working on the DID method, some of the DID method specs, for example. So in the community group is where you can go to, if you want to develop a DID method, you can go there to sort of coordinate with people to learn how you would go about it, how you would write your method spec. We also maintain sort of a registry of DID methods. Let's see. Oh, and also the other thing I wanted to mention, Marcus's work with the Universal Resolver, he's done that with the Decentralized Identity Foundation. So that's also another very active area. So as people are adding more DID methods, the Universal Resolver is updated to support these. Some other ones that I wanted to call out that the Decentralized Identity Foundation is working on would be, DID auth, so what it means to authenticate with the DID. And then lastly, so I have pointers in the next slide to the GitHub repos that I mentioned, but Also check out Ryan Grant and Dan Pape's C++ repo, where they're doing a lot of active development work right now. You can see some more information about the extensions that I talked about that are already underway. And lastly, there's a whole bunch of references here to find a range of information and groups if you want to follow up with us and get involved. And yeah, so thank you, everyone. And at this point, it looks like I finished a little early. So if anyone has any questions, I think we'll find out.
Yeah. There are no questions right now, but I have a couple of questions.
Yeah.
Just how are you using the BTCR method as part of what you're doing at Learning Machine? I mean, what are the use cases you're thinking about how you will be able to apply them?
Yeah. So for us, we're very focused on two scenarios. So one is that recipients are getting claims from their institutions about their educational or workplace accomplishments. So we want the recipients to, right now, in the first release, what we did to make the cryptographic key management easier for recipients was to basically use the key management parts of a Bitcoin wallet. So it solves some aspects of it, but there's still the usual warnings like, write down your mnemonic seed. If you lose this, you lose this sort of ability to show that you own that. So we knew pretty much as soon as we heard about it that DID is the right place to go to give a more future-proof approach. So we're approaching it in two ways. One, it's really critical for recipients to be able to use the DIDs as the subject of the credential that they're receiving. And two, on the issuer side, you can also use DIDs on the issuer side as saying, an issuer by their DID. It has associated with that DID a whole set of keys, which you can, say, yeah, that's actually that person's signature. And so that gets into some of the other, or it addresses some of the other usability problems also on the signing or issuing side. So yeah, those are the two areas that we're interested in it. And they're both from a sort of longevity kind of angle of concern. The other thing, though, that's interesting on the issuing side is that one thing that I really like about DIDs is that they factor in the life cycle of the keys, in a much more first-class way. So it's common practice, it's suggested practice, good practice to rotate your cryptographic keys. So what happens if you have a verification method that's based on, cryptography and the issuer rotates their keys? Do they have to, sort of reissue every credential that they ever issued? There's sort of that as an ongoing problem. So, there's ways that we've gotten around it, like in terms of both the LD signature spec and sort of the block cert spec, which is a time-stamped approach to these keys. But the thing that's appealing with some DID methods anyway is that you have the opportunity to sort of timestamp DIDs in certain ways, and that's something we're still talking through the details of in the credentials community group. But how that would work would be something like, okay, someone presents you a credential and it was signed by an issuer, DID effectively, and you want to see, you want to look up the transaction information and make sure that's actually authentic. So the issuer may have rotated keys in the meantime, but through a timestamp aware DID resolver, in theory, you can say, well, what did the DID look like at this point in time? And so you can say, yeah, that's still valid, and you avoid the problem of issuers having to reissue credentials. So that's one of the biggest reasons that DIDs have been appealing to me. It's the idea that it addresses these life cycle concerns in a more first-class way and make sure that we're not putting off the problem of, what happens if this key gets revoked or something, where what you don't want is for people to just end up having to keep re-requesting the credential, and then you're not much better off than where we are now. So, yeah.
Awesome. David is asking us why Bitcoin rather than, say, Ethereum?
Yeah, that's a good question. I think for it's a combination. Bitcoin being, a very not to say Ethereum is not trusted. Bitcoin it's very simple. When you're on Ethereum, you actually have a lot more options, in fact, and you might not even approach it in the same way that we did. So we're just sort of doing a pretty standard, with the exception of the op return, Bitcoin transaction, very limited amount of data, but also very, I guess I would say, foolproof. Like, we don't have a contract that's managing identities. Now, you could also do that style of issuance on Ethereum as well. It was just mostly the sort of, the quote unquote trust associated with the Bitcoin blockchain. And there's no reason this can't be done on Ethereum. And there are actually some really good DID methods that are Ethereum based. And they're more, I would say, more complex, more feature rich than BTCR. BTCR is by design very simple, and which again gives you, more confidence security wise if you are, sort of just looking for a quick way to bootstrap into the DID system.
Okay. Is there anyone else working with the BTCR method besides Learning Machine, or are there also other companies that are using this method?
So that's one thing. I'm not. I think Ryan's company is working with it in some way, and for Learning Machine side, we're more interested in it from the perspective that it's very usable right now. We're very interested in actively pursuing other DID methods. So we're very interested in the interoperability angle, but also from the angle of, say, through the block search standard, if we're to start suggesting people use DIDs, we need to have something that people can actually use. As always with open source, you're reluctant to say use this specific, company related thing, and that's why BTCR is just sort of general openness, not being associated with a company, is sort of appealing from an open source perspective too. But I should mention that, for example, we're very interested in allowing other forms of DID, participation in the credentials.
Mm-hmm. Just one last question. I'm wondering about what is the progress of the work in terms of making all the different DID methods interoperable, or is that something outstanding for the future?
Yeah, I think that for those, it's varied. It's kind of funny, I guess. It's sort of restricted on a bunch of very busy people who are writing the code right now, and so we tend to be pretty bursty, and you'll notice a lot of activity around certain events where we'll sort of set time aside and make a lot of progress all at once. So I think that I do think that of the ones that I've seen, maybe like Uport, Verus1, Evernym, Sovereign being maybe farthest along. With BTCR, I don't think we've actually published a lot of it. In terms of the content we have, we're getting far along. And this is something that we're all aware of, and we have a hard deadline, is the good news. We need to have a lot of our method specs published well in advance of the DID working group formation. So that's we want to have that happen in fall. So I think you're going to be seeing a lot more real live DID method specs in the late summer.
Okay.
Yeah, most of us we have hard commitments to that, so.
Yeah, no, that's excellent. Good.
Yeah.
Is there anything else you want to mention, Kim, that you think is relevant?
No, just another plug to join us. We're really looking for people to get involved, and so in that slide where I have the references and links to the various groups, a good way to get introduced to this whole space before sort of going into a W3C group would be through either a combination of IIW, the Internet Identity Workshop, Rebooting Web of Trust. Both of those are a good way to sort of absorb a lot of information and just start experimenting with this stuff and being around people who know a lot to learn about it. That's really been the way that I've gotten my information. And then also specifically for block certs, if you're interested in helping sort of prototype DIDs within the context of block certs claims, that would be something that would be another thing as well. That's more immediately applicable. Now, certainly if you're willing to get more heavily involved, we're always looking for people to get involved more at the specification level. If you want to help with the edit the method specs or anything along those lines. Yeah, so just review that link, and you can reach out to me on Twitter if you have any questions.
Awesome, great, fantastic. Thank you very much for your time, Kim. For everyone who's interested in learning more about SSI, we will keep on doing this as much as we can. Next week, we will have Daniel Houtman from Evening, who will be talking about the different dimensions of identity. And just sign up to the newsletter on the website, join our Telegram group or Twitter or Facebook or LinkedIn, all those different channels. We distribute the content all across those channels, so you can learn more about all these things. Also, please come forward if you're interested in presenting any subject. Just get in touch. And that's it for today. Thank you very much, Kim. It was great having you with us today. And I hope we will have you and your team many more times with us here at SSI Meetup, and so that everyone can learn from you and also share this knowledge with the rest of the world.
Great. Thank you so much.
Thank you.